Now, we will explain about set. What is the definition? So, number 1, set. A set is a collection of objects that can be clearly defined and measured so that it can be known whether or not they are included in a certain set. Number 2 is non-set. If it is not a set, it means that its member cannot be clearly determined and cannot be measured. Now, for example of set, number 1, the set of natural numbers. Number 2, the set of prime numbers between 10 and 14. Number 3, a collection of class 3B student names beginning with the letter B. Now, for example of non-set, number 1, an interesting collection of paintings. Number 2, the association of smart people. Number 3, a good set of colors. Next, expressing a set can be expressed in 3 ways. Number 1, with words. Example, P is the set of prime numbers between 10 and 30. Written, P equals to set of prime number between 10 and 30, like this. Number 2, with set from notation. For example, P is the set of prime numbers between 10 and 30. Written, P equals to set of X is more than 10 and X is less than 30 when X element of prime numbers between 10 and 30, like this. Number 3, by registering its member. For example, P is the set of prime numbers between 10 and 30. Written, P equals to set of 11, 13, 17, 19, 23, and 29. Set cardinality. So, the definition, set cardinality is the number that expresses the number of numbers of a set and is denoted by NA notation. NA or absolute value denote the cardinality of the set. Example, suppose that B is the set of odd numbers that is divided by 2. Since there are no odd numbers that are divisible by 2, A has no members, so it is an empty set. Written as B equals to empty set like this, or B equals to empty set like this. So we next to empty set. Definition. An empty set is defined as a set that has no members. The empty set is denoted by this empty set or this empty set. Example, A equals to set of x is such that x is less than 6 when x positive integer. A equals to 5, 4, 3, 2, 1, and A equals to 5. Subset set A is a subset B if each member of A becomes member B by denoting A subsets B or B superset A. Next, set of universe definition. The set of universe or the set of speeches is a set that contains all members or objects of the set in question. The set of universe is usually denoted by S. Example of the set of the universe. Suppose A is equal to set of 2, 3, 5, 7. Then the possible universal set of set A is as follows. S is equal to set of prime number. S is equal to set of natural number. And S is equal to set of whole number. Venn diagram. A Venn diagram is a way of expressing a set using an image. In the Venn diagram, the set of universes is represented by a rectangular area, while the other sets in the whole discussion are represented by simple closed, smooth curves and dots to represent their members. Function characteristic. Slice. The slice of two sets A and B is a set whose members are in set A and are in set B. The slice between two sets is denoted by a sign like this. Combine the combination of two sets A and B is set whose members are a combination of members of set A and set B. The combination of two sets is denoted by a sign like this. Complement. The complement of a set is the elements that exist in the universal set. Except for members of the set. The complement of A is denoted, pronounced A complement.
Relation and function. In a relation, there are no special rules that must be met to match members of the regional association to members of friendly regions. Each member of the regional association of origin can have more than one partner or might not have a partner at all. The relation of two sets can be expressed in three ways, namely a row diagram. That's you can see the example of row diagrams. Cartesian diagram. That's you can see that's example of Cartesian diagram. The set of constructive pairs. Example, Aldi likes red, Nita likes purple, Yuli likes black, Chacha likes red. From the description above, we can state the relation with the set of constructive pairs as follows: Aldi red, Nita purple, Yuli black, Chacha red. Relation characteristic. There are the first reflexive. The relation R or set in A is reflective is A, A element R or every A element A. 2. Symmetrical. The relation R on the set A is called a set if A, B element R, then B, A element R of all A, B element A. The third anti-symmetric relation R on set A is called antisymmetric if A, B element R and B, A element R. Then A equal B for all A, B element A or A, B element A. Transitive relation R. On set A is transitive if A, B element R and B, C element R. Then A, C element R for all A, B, C element A. Function. A function is a relation from set A to set B if each member of set A is paired with exactly one member of set B. The result of mapping between domains and domains is called the function. Range of result area. The first domain is A equal to 1, 2, 3. 2. Codomain is B equal to A, B, C, D. The third range result is equal to A, C, D. Function can be denoted with lowercase letters such as F, H, E, and so on. The function F maps set A to set B, then it can be denoted by function from A to B. Function characteristic. The first, injective. The function F is said to be injective if no two elements of the set A have the same image. The second is surjective. The function F is said to be surjective if each element of set B is an image of one or more elements of set A. The third is bijective. The function F is said to be bijective if the function is an injective and a subjective function. Okay, that's all about our presentation about set.